In the corporate world, it's necessary to have high availability and scalability of networks. Usually networks are wisely planned to handle the required capacity of corporations. Network administrators use baselining, and then they refer to this baseline in order to detect abnormal network behavior and possible network issues. Let us go directly to Wireshark and explore some quick techniques on how to detect issues. Just take a random sample here. The first thing you need to know when you want to detect issues is to press on the expert system down here. The expert system has errors, warnings, notes, and chats. Errors refer to serious problems. Warnings refer to possible problems. Notes are things that might be of an interest to you, and chats are the usual flow. You can hide the notes and hide the chats and focus on the warnings and the error. When you press on the error here, Wireshark will take you directly to the packet in question. Another technique to use is to go to the View menu, then Time Display Format, and use seconds since previous captured packet. I'll select that. I'll go to the same menu again and use milliseconds. This way you will see the difference in time between the current packet and the previous packet, which will actually show you the latency. If you go down, you can spot some major issues by just spotting a high number. For example, here we have 42 milliseconds between this packet and this packet. You can as well go to Statistics, then I/O Graphs. In order to visualize all the packets, you can as well tick the TCP errors to compare the errors to the current packets. In this case, we have a minimal set of errors. Now I'll go to this file. It's a BitTorrent file. One of the first tasks you need to do in order to detect malicious traffic is to go to Statistics, then Protocol Hierarchy. It will directly highlight some unneeded traffic on your network so that you can take some action. Now I will go to this packet capture that I run after using Tor browser. Again, if you want to spot some malicious activities on your network, go to Statistics, then Conversations, and you can either go to TCP or UDP. UDP is empty in this case, so I'll go to TCP, and you can spot some unrecognized ports here. For example, this port 9001. You can do a small search on the internet, and it turns out that the port 9001 is malicious. This is the protocol name used. It is used to transmit viruses and trojans. Just by simple query over the internet, you can spot these issues. Some of the other reasons that can cause congestion on your network is the high usage of voice over IP or streaming protocols. Low bandwidth occur when multiple hosts contend for the same resource over your network. So it's probably wise to check the broadcast traffic that we've learned earlier in this course, such as DHCP and ARP, because these two protocols use broadcast traffic to operate, and in case there were many hosts on the network, this can cause a lot of traffic. You can as well fine-tune some devices that use multicast and check if the IGMP protocol is correctly configured on those endpoints.